Okay, so yesterday we were working on this problem, and I got kind of tripped up in class because I thought that there was something wrong with my intercepts and my horizontal asymptote, and all of our math was correct. But and later, as I was thinking about it, I realized why there was an issue, and a lot of why we were confused was because I didn't do a very good job explaining horizontal asymptotes. So horizontal asymptotes are, yes, where your graph can't cross horizontally, but it actually can cross. And same thing with a vertical. But okay, so your asymptotes are where your graph, your end behavior occurs. So for a horizontal asymptote, it's where what's happening to your ends as I go out horizontally. So if this is my coordinate system, a horizontal asymptote is what is happening to my ends as I go to positive infinity and to negative infinity on the x. That's why a horizontal asymptote is a y equals. So in our problem, our horizontal asymptote occurs at y equals a half. That means as I go to positive infinity, my ends cannot cross 1/2. And as I go to negative infinity, my ends can't cross a half. They're going to get really, really close to a half, but they're never going to touch a half. And it's just at the ends. That's why yesterday when we were doing that one where we can cross in the middle, that's okay because that's not anywhere close to your horizontal ends. As my x values are going out to positive and negative infinity, a horizontal asymptote is where they converge. And that's the same thing on your verticals. Your verticals are as I'm going to positive and negative infinity on the y's, what is happening to my x? So for the ones that we had 1 and 3. As my values are going to positive infinity or negative infinity, they're going to get really close to x equals 1 and x equals 3, but they're not going to actually touch those. That's why they can't cross them as you go up and down. In the middle, theoretically, they probably could, as long as your end behavior does, but your end behavior runs up and down, so you're really not ever going to cross a vertical axis or vertical asymptote. You may cross on a horizontal. And I hope that's clearing that up for you, and I'm sure it's not, but maybe by finishing out this example, it'll make more sense, and if not, then, we're going to keep working through these. I'm in no rush to finish these, so as we work through them, it'll be fine. So let's go ahead and continue graphing this. So this was my coordinate, and I'm just going to, or this was my x-axis, and then my y-axis, and I'm just going to put in some lines, plot them. So let's start by plotting my x-intercepts. So I have an x-intercept at -2, 0, and I have one at 2, 0. And then I have a horizontal asymptote a y-intercept at 0, 4/3. So here's 0, 4/3. And then we have vertical asymptotes at x equals 1. And x equals 3. And then we have our vertical asymptote here at y equals a half. Okay? So one of the things that we discussed is that I'm going to be coming here, right? Coming from that y-intercept down to my x-intercept at 0, -2, or -2, 0. And that's where we thought we were having the issue. And we can cross there, that's okay. As long as my end behavior ends up, when it bounces, because it is going to bounce here because that has a multiplicity of 2. When it bounces back up, it has to bounce and not cross a half. So it's going to come back up, it's going to come down, and then go right back up. And as it goes up, it's going to come along this line, and it's never going to cross the line y equals a half. Okay? But it is going to keep coming up this direction, and as we come up that direction, we're going to approach but not cross the line x equals 1. Okay? So then we know that at x equals 1, that has a multiplicity of 2, so our ends are going to be the same. So if we're going up here, we need to be going up here. So we can come in here. At this x-intercept, at x equals, at 2, 0, we can cross. So we're going to cross along that and keep going down. And it's going to go down forever. It's going to close to 3, but it's never going to cross at 3. And then at 3, we know that my ends have opposite behavior. So if I'm going down this direction, then I need to change my behavior and I need to start going up. Okay? or no, if I'm down, I'm going to be going, my end behavior has to be going up on the other side of that intercept, or asymptote. Okay? But remember, as we bring this down, it's not going to be able to cross the horizontal asymptote because I have to keep going forever to 1/2. Okay? So it's not going to be able to cross that because as it keeps going down, it's going to start approaching 1/2, and we're not going to be able to cross there. And the reason it can cross here is because that's not towards your end behavior. Since it bounces there at -2, it's going to eventually bounce and then keep going out. And so it's okay that it crosses there because that's not an end behavior as we approach infinity or negative infinity. And that's where your horizontal asymptotes come into play. So I hope that clarified it. And if it didn't, I'm going to do a couple more examples and hopefully it'll clarify it a lot more than that. So I'm going to do another graphing one just to make sure that you guys get a little more. We only did those 2 examples yesterday and I felt like it wasn't very good. And I want to make sure you guys understand what we're doing. So this is an example from the book, and we're going to graph f of x equals, x plus 2, x minus 3, and then we're going to graph x plus 1 squared, x minus 2. So I start out by finding my x-intercepts, and my x-intercepts are where my top equals 0. So at -2, 0, and at 3, 0. I checked multiplicity on those. They both have a positive exponent, so neither one of them is going to, they're both going to cross. Neither one of them is going to bounce, okay? So hopefully that makes sense. So then we're going to go to the next step, which is to find my y-intercept. So for your y-intercept, you're going to let x equal 0. So if I let x equal 0, on top that gives me 2 times -3, which is -6. And on the bottom that gives me 1, because 1 squared is 1 times the -2. And that gives me -2. So my y-intercept should be at 3. Remember, we always write these as ordered pairs, so this ordered pair is at 0, 3. Sorry, I was waiting for you guys to write, give you time to write that down, and then I started doing something else. Then we want to do our vertical asymptote, so that's where my bottom equals 0. So my bottom equals 0 at x equals -1 and x equals 2. And I'm going to put that so I know that for the -1, my multiplicity there is 2. So since the multiplicity is 2, that means my ends are going to have the same behavior. And for x equals 2, that has a multiplicity of 1, so my ends are going to have opposite behaviors. Last thing I do is my horizontal asymptote. The degree of the top is 2, and the degree of the bottom is 3. So if you go back and you look at your rules for horizontal asymptotes, if the degree of the top is less than the degree of the bottom, then the horizontal asymptote occurs at y equals 0. So since our top has a degree of 2 and the bottom has a degree of 3, we have a horizontal asymptote at y equals 0. So now we're going to put all that together and graph. Okay, so I'm going to start with plotting my x-intercepts. Well, my x-intercepts occur at -2, 0, and 3, 0. So -2, 0 is here. Oops, well, right there. And 3, 0, that's right there. So those are your x-intercepts. Then we're going to graph our horizontal asymptotes. So our y-intercept. God, I'm sorry. My y-intercept is located at 0, 3. So here's 0, 3. Then I'm going to graph my horizontal asymptotes. So those occur at x equals -1 and x equals 2. There's my asymptotes there. And then I've got to go ahead and my y-intercept, or my vertical, whatever this one is, horizontal asymptote is there at y equals 0. And see, like, look, your x-intercepts occur on the horizontal asymptote sometimes. So that's another reason why it can, like, we know that it can cross there. Okay, so let's go through and now do our end behavior. So there's not really a good way to do this, because every time we've done one before, your x-intercept and your y-intercept have either been inside the asymptotes or they've both been on the same side as one of the asymptotes. But see, here you have them, one's outside and one's inside. So you can't connect them by going through the vertical asymptotes, because you can't cross the vertical asymptotes going up and down. And so what you're going to have to do is just plug in a point and see where it goes from there, to see if it goes up or down or those kinds of things. And so I'm going to go ahead and I want to see what's happening here at this asymptote. So what I'm going to do is I'm going to plug in x equals 1, and I'm going to see what the behavior does at x equals 1, and then I'll know what's happening as I go from my y-intercept to that I'm sorry. We're going to see what happens when we go from the purple to the point that we're going to plug in. And we're going to do the point that we're plugging in orange. So I'm plugging in x equals 1. So when I plug that into my equation, I get 1 plus 2 times 1 minus 3 over 1 plus 1. That looks like crap. I'm going to erase that. And then 1 minus 2. So if you do all that and you plug it in and you check it out, you get 3 times -2. 3 times -2 would be -6. And then on the bottom, you're going to get 2 squared, which is 4. And 4 times -1 is 4. So we're looking at something I did wrong. Oh, because that's a -1, so that's a -4. So I'm going to get 6 over 4, which is 3/2. Okay, so when I plug in 1, I'm going to get 3/2, which is about 1.5. So it's happening right there. So as I go from purple to orange, I'm coming down. Okay? So that actually doesn't quite help me that much, because I need to know if it's going to go back up or if it's going to go down. I don't know. I don't know if it's going to keep going down. That didn't actually help me finish my end behavior. So I'm going to check another point, okay? And I'm going to check, this time I'm going to check 2. And I know that it's a vertical asymptote. I know I can't hit that point, but I can get close to it, so we'll just see what happens there. And it is going to make, well, it's going to make your bottom 0, so I don't actually know how that's going to help. So I guess actually we're going to have to plug in 1.5 just to see what happens. And if you plug in 1.5 for your x value, I'm going to do this on the calculator so I can use fractions. And I'm really just trying to find approximately what the value is. So if I plug in 1.5, I get, well, I'm going to do 1.5 plus 2 times 1.5 minus 3 over 1.5 plus 1 squared times 1.5 minus 2. And here's the thing, like, if you're worried about what's happening on your end behaviors and all that kind of stuff, like, all you have to do is plug in points and see what's happening. That's the best way to get there. I mean, I know it's not the most time-efficient way, but, like, if you don't know what's happening and you don't have a picture of it and you're not going to be able to graph this on a calculator, this is what's going to have to happen, okay? So I get 3.5 times -1.5 So that gives me negative 5.25 on top. And on the bottom, you get 1.5 plus 1 squared. That's 6.25 times 1.5 minus 2 is negative a half. So 6.25 times 0.5 is negative 3.125. So negative 5.25 divided by negative 3.125 comes out to be 1.68. So when I plugged in 1.5, I get 1.68 for my. So what that tells me is that when I plot this point, when I plug in 1.5, I get 1.68, which is bigger than 3.5, so it is going to go back up. And that's actually too close. It's going to go back up. So it's going to come down and then go back up. And the reason I had to do all that work is because I need to see what's happening as it approaches that side. So it's going to keep going up forever and ever and ever, whatever. And this one's going to keep going up forever and ever and ever. And we get this U shape here in the middle. And then what I know is that at this x equals 1, or at this x equals 2 asymptote, that my ends have to be opposite. So if I'm going up on this side of the asymptote, then I have to be going down on this side of the asymptote. And I know that I'm going to come up here to this intercept, and I'm going to have to cross it, okay? But as I cross it, I'm going to cross it, and I'm going to go out to infinity, okay? And it might cross, and it's probably, like, as it crosses, and we can't tell by the way I drew this, but it's going to cross, and it's probably going to start heading closer back down to x equals 0, or to y equals 0. And then on the other side, I know that at this asymptote, the ends have to have the same behavior. So this has to be going up. So I'm going up. I know I need to cross here, but then I need to go out and start heading back to y equals 0. And that's what your graph looks like. And we're going to have plenty of practice with graphing, so hopefully we're okay. Pause this as you need, and we'll make it happen. Okay, so the last thing we're going to do is writing the equations. So I'm going to start by giving you the graph. So on this graph, they've given me certain pieces of information. They gave me that I have intercepts at -2 and 3. And so I'm going to write this information down as I go because this is going to help me write my equation. So I have intercepts at -2, 0 and 3, 0. Okay. And I have a y-intercept at -2, 0. And it tells me that I have vertical asymptotes at x equals -1. And x equals 2. I don't know why I drew the. You can draw the arrows if you want. You don't have to. And here's what my picture looks like. And this is a really crappy version of what it looks like. So if you want to see a not crappy version, look in the book on page 429. Okay, so this is what we're given. And we were given all this information. I'm also going to put that we had, I forgot to put our vertical asymptotes down. And those were at x equals 2 and x equals -1. Okay, so I've got to write an equation. All right, so I know that to write the equation, I have to have f of x equals, and it's going to have a fraction. I know that because of my vertical asymptotes, that means that my bottom has to be x minus 2 and x plus 1, because it's like I would be setting those and like getting them back to 0. So x equals 2. To get it back to 0, would subtract 2 from both sides, and you get x minus 2 equals 0. That's how we're getting those. I do have to worry about multiplicity on those. So if you go look at your graphs, see at x equals 2, how both ends are going the same way. That means my multiplicity must be even. Okay? And for our purposes, we're just going to say it's just squared. And for the multiplicity on the x plus 1, because they're going opposite directions, we know that that has an odd multiplicity. So we're just going to say it's just 1. To find the top, that's where your x-intercepts are coming into play. So I have an x-intercept at negative 2, 0. So that means that I have x minus 2, or x plus 2, I'm sorry, and x minus 3 on top. I do have to worry about multiplicity on those. Since it crosses at both of those, that means they both have a odd multiplicity, so we're just going to assume that they're both 1. Now, in front of all of this, there's an a value. Anytime you're writing an equation, you don't know if it's stretching, shrinking, anything like that. So you have to be able to find if there is an a value, or to find out where those things would be. So to find that a value, we're going to use our y-intercept. And so what we're going to do is we're going to plug in the y-intercept, so negative 2, 0. So that means my y value is negative 2, and I'm plugging in 0 for my x's, so 0 plus 2, 0 minus 3, 0 minus 2 squared, 0 plus 1. And when you work all that out, you get that you have negative 2 equals a times negative 6 over 4. To solve for a, you multiply by the reciprocal, so 4 over negative 6. And then you do the same thing to the other side. And so that tells you that a is 4/3. So your final equation is going to be f of x equals 4 times x plus 2, x minus 3, over 3 times x plus 1, x minus 2 squared. So your final homework for today is that you are going to do page 5.6, and I'm going to leave you a couple extra graphing ones. So you're going to do 40 through 50 even. You're going to do 51 through 56 all, 57 through 63 odd, and then 80, 81. So that's your homework for today. These are graphing. It's the rest of the graphing, and then the rest of this is all writing equations. For your a value, just pick your y-intercept. It's the best way to do it. And if you guys need any help, I will help you when I get back on Thursday.